everyone. This is Zohaib Ahmad and today we'll be discussing incineration processes in solid waste management. Previously, we had a brief introduction about the three processes which were incineration, gasification, and pyrolysis, and we learned about the thermal conversion technologies, how the organic matter or the organic waste gets decomposed with the help of combustion, or you can say with the help of heat. Previously, in our previous lectures, we were discussing about composting, that how anaerobic and aerobic bacteria convert the organic matter and the waste material to the compost. Here we are using heat as a medium to decompose the material, to decompose the solid waste. So let's begin. As we know, incineration is the treatment of waste material by the combustion of organic substances present in the waste material. So incineration is the treatment of waste material by combustion. Combustion means the process of burning. So we are burning our organic substance. I have used the term organic substance, but in incineration, both inorganic and organic substances are heated to reduce the volume and to have byproducts as well. So the major byproduct which we get from incineration is bottom ash. Bottom ash accounts for around 80 to 87% of the solid residues. So as you can see, the ash which is like in the major proportions, which is the byproduct of the incineration. Some flue gases here means that it will have traces of nitrogen dioxide, carbon dioxide, and sulfur dioxide. So it will have some byproducts which will be beneficial for us and some which will not be beneficial for us. Let's move on. So it's diagrammatically represented how the incineration process works. It's very simple. You have the solid waste, you dump it in the combustion. Combustion means burning. You then, after burning at a temperature of more than 900 degrees Celsius, heat is generated. Due to heat, steam is generated, and that steam drives the turbine which generates the electricity. So here it is mentioned as energy production. Here you can see gas cleaning is written over here, which actually means that because flue gases such as carbon dioxide and some very harmful gases like nitrogen dioxide, which is very harmful, are generated. Nitrogen dioxide is an irritant gas, so it is very harmful for the human beings. So gas cleaning is a very must in incineration because it has a disadvantage that it pollutes the environment. Incineration pollutes the environment because it emits more carbon dioxide than a coal-based thermal power plant. So the gas cleaning work is done in the incineration process. We'll be discussing that later on. So this is the desirable waste treatment and desirable proportions of the waste that should be put into the incineration plant in order to have a better energy in terms of calories. Like you can see, moisture content should be less than 45%. We have discussed that moisture content should not be very high because it inhibits with the incineration. The organic substance should be more than 40%. Fixed carbon should be less than 15%. So while using this process, we have to make sure that the solid waste that we are putting into our incineration plant, that we are putting our waste to heat, it should have these following parameters in order to have a good high energy value, so that we can further use it. If the energy value is less, definitely it is not much of use. So we will not be able to utilize more of the solid waste energy or the biomass energy. See, this is the incineration process. You can see here you can see that there is a hook. It is actually putting solid waste from here to here, and you can see that it is a furnace in which burning of solid waste is taking place. You can see over here that when burning of solid waste takes place, hot gases they tend to occur, and these hot gases and these steams which are generated are in turn used to generate heat and electricity, and then used in boilers. So we have different points to be discussed, such as let's begin with the combustion. Here you can see the combustion. Waste is continuously fed into the furnace. See, waste is continuously fed by the overhead crane at a temperature more than 850 degrees Celsius for more than 2 seconds, with sufficient supply of air so as to ensure complete burning of the waste. and to prevent formation of dioxins and carbon monoxide. Secondly, as you can see, it has boiler and boiler. It has written over here boiler. The heat from the combustion, that is the heat that is generated from the combustion, is used to generate steam in the boiler. Right? It used to generate heat, steam in the boiler. The steam then drives the turbine. Basically, it drives the turbine, which is coupled to the electricity generator, and hence it is used for the electricity generation, which is very much evident from the picture over here. Then comes the part which I was talking about, the exhaust gas cleaning. So exhaust gas cleaning. So exhaust gases from the boiler. Basically, they are very harmful gases, as we have discussed. These are nitrogen dioxide, carbon monoxide. So they have to be cleaned. So how they are cleaned? Due to this equipment, exhaust gas cleaning, we are able to clean our gas as well. And that gas, after cleaning, is goes to this chimney, and thereby it moves to the atmosphere. Then we have certain terms as activated carbon injection and dry or wet scrubbers as well. You can read it from here also. Combustion, boiler or steam turbine, exhaust gas cleaning. That exhaust gas from the boiler is cleaned by the advanced pollution control system. And further, we have a dry or wet scrubbers. Dry or wet scrubbers, basically they remove the polluted acidic gases like sulfur dioxide and hydrogen chloride are coming from the boilers. They are used to remove those polluted gases. And then activated carbon injection to remove heavy metal and organic pollutants in case there are any. And last is the baghouse filter. You may not be able to see the baghouse filter because it's not a 3D image. Basically what it does, it's filter and removes the dust which is due to the gases and everything, and remove dust and fine particles. So this is the whole process of the incineration, how it takes place. Let's next move on to the type of the incinerators. Basically, incinerators have three types. Rotary kiln, moving grate, fluidized bed. Let's just move on to rotary kiln. So rotary kiln is just a second. Rotary kiln, yes, you can see over here. It's a rotary kiln incinerator. It is somewhat, the first chamber is somewhat inclined. The principal design basically consists of two thermal treatment chambers. It will have a slightly inclined primary chamber which is fed in together with inlet of hazardous waste or your solid waste as well, in together with inlet of hot exhaust air with oxygen, rotated and thermally decomposed by the heat radiation from the secondary chamber. Here you will have the secondary chamber. The recombustion chamber positioned at the rear of the kiln. This recombustion chamber which is at the rear of the kiln, with the decomposition, the decomposed air and the rest waste is completely burnt with the supply of secondary air. Basically, we are again burning the waste with the help of secondary air. So since the process is done twice, since initially it was having a inclined pre-chamber which is decomposed, and then again we have a recombustion chamber which is positioned at the rear end. So it is decomposing with the help of secondary air as well. So the advantage of it has the advantage of producing a low level of nitrogen oxide (NOx) and thermal destruction of hazardous chemicals. Right. So it will have a reduced, you can say, have a reduced effect. Like we have seen in incineration process, it's one of the incinerators which has this advantage. Secondly, let's move on to moving grate incinerators. Moving grate, as the term says, that it is moving grate. So there is nothing new in there is nothing not to be understood, because it is moving grate. Moving grate means this belt here is moving, and the waste from municipal solid waste, it is numbered as one. One is the feed hopper. From here you put the solid waste, and in this belt it keeps on moving. And this has a furnace in below this. So the waste is continuously getting burned, and you can have the bottom ash which is being discharged over here. Bottom ash, the waste which is burned, the bottom ash collects over here. So basically, it has waste is dropped by a crane onto the descending grate, which moves into the combustion chamber, and then eventually moves down to drop the burnt residuals into the ash pit at the other end of the grate. The moving grate, basically, if I talk about the material, then it's a metallic porous bed allowing primary combustion air. Here it will you can see that secondary air distribution as well. That we will have a secondary air distribution from this 4 is mentioned over here. So secondary combustion air is supplied by nozzles. It's from the 3D image, so we are not able to see the nozzles, but it has nozzles which provides a secondary combustion air, and it facilitates a complete combustion by the introduction of turbulence. So with the help of turbulence, uniform mixing occurs and a complete combustion takes place. And whenever a complete combustion takes place, the amount of gases that occurs, that the harmful gases are less. Then you have at 7 you have flue gas burnout zone. The flue gas such as carbon dioxide, nitrogen dioxide, they just the gases, then the evolved gases moves from this portion to this portion, and then you have separators, and then you have steam drums, evaporation surfaces, and feed water preheating surfaces. Then it goes on, and the flue gas goes towards the cleaning treatment. So this is the moving rate incinerators. The fluidized bed incinerator. The fluidized bed incinerator will have a it is not an image with the fluid. You can say that it is suitable for the industrial and sewage sludge incineration process. And basically, a principle of fluidization is the process where a granular material in a solid state is turned into a fluid-like state by passing a fluid, a liquid or a gas, maybe a gas, because gas is also a fluid. Through it, as the fluid passes through the granular material, the drag forces they overcome the force of gravity, and material expands as the particles are moved away from each other. So eventually, as the fluid and material spreads further apart, the velocity slows, and the force of gravity basically overcomes the drag forces, causing the particles to fall back down until they begin to fluidize again. So given sufficient velocity, the particles they remain suspended or fluidized and will exhibit a fluidic behavior. So from here you have a preheater burner which will have sand as well, which will the preheat burner which it has some fluidized sand bed which mixes violently and serves to distribute and break up the sewage sludge. Basically, you will have a sand bed over here which will distribute and break the sludge so as to reduce the volume as well in this. So it provides a large surface area as well, and the procedure remains the same. You are heating with the help of auxiliary burner over here. Solid waste is put from here. Preheater burner is here, which is continuously providing sand. Due to the sand, it is breaking up the particles. And from here, waste, ash, recycle, and bed make up feed. Auxiliary fuel and air. You can you have the ash and bed removal. The exhaust gases they release from this portion, and this you have just the free board. It is called as the free board, which is the empty space. It is the free board disengagement where the gases are escaping through this. So these are the 3 types of incinerators. So basically, I would like to say that the advantages of the 3 is basically you can say the enhanced combustion efficiency. However, we can say that in fluidized bed incineration, due to the homogenization of waste, like we have a fluid air which is there. So basically, due to the mixing of the solid waste with the help of air and with the help of sand bed, it is actually breaking up the sewage sludge as well. So it has the enhanced combustion efficiency. So it is one of the advantages. And so we have discussed till now 3 kinds of three kinds of incinerators. Further in the class, we will discuss about the incineration with heat recovery, and we will furthermore I will tell you about the byproducts, utilization of the byproducts during incineration. They're like how ash is utilized, how the flue gases are utilized, and then we'll talk about RDF, which is very important, which is refuse derived fuels, and where it is used, how it is produced. We will discuss about that. So that's it for now. We will discuss gasification and pyrolysis in our upcoming lectures and the remaining portion of incineration as well. Thank you.